Okay, so Unit 8, we're going to start with Section 10.1, which is radical and radical functions. Okay, so when you're looking at radical functions, you're just talking about square roots, cubed roots, fourth roots, those kind of things, right? So the simple one, a square root is a number that when squared, which of course just means multiplied by itself, okay, is going to be equal to the given number. Okay, so if they give us something like the square root of 25, it's asking what number squared would give me 25. That's what it's talking about. Okay, these things are called radicals, and a radical is a way to symbolize the root of a number. Okay, the root of a number. So radicals have three different parts essentially. Okay, there's the radical sign. We always call it the square root sign, but it's actually called a radical sign because there can be things other than square roots, right? Because a radical is going to symbolize the root of a number, which isn't always square. So the radical sign, right, which is this thing right here that we always call the square root. Okay, underneath that radical sign is the base. Okay, and the little number that sits right in here is called the root. Now, if there's no root written there, like here, okay, we always assume that root to be a 2, so it is a square root. So unless rooted, right, unless rooted, we will know the root to be 2. Okay, so unless it's rooted, we'll know the root to be 2. So if I look at something like this, so you're looking for what number times itself gets you to 25. Well, the easiest way, now obviously this is pretty simple. Everybody at this point in your life should know the square root of 25 is 5. Okay, but the reason why, the way that works out is that if I were to take this and break it down, right, 5 times 5, so that 5 times 5 would be a number times itself, which gets me to 25. So I get 5, because here I'm looking for a square root, so I'm looking for groups of 2. Okay, and I'm pointing that out because later on we're going to do stuff that's not just square roots. We're going to look at cubed and fourth roots. Okay, if there's a negative out in front, okay, your negative just stays out front, so we just said the square root of 25 is 5, and that negative that's out front just stays out front, and the square root of 25 is 5. Okay, a negative underneath. Okay, some of you might be aware that a negative under an even-rooted radical is going to give me an imaginary, but we're not going to go into imaginaries just yet. Okay, so for right now, you can't have negative under an even root. Okay, so what I mean by that, negative under an even root. So I have a negative underneath the radical, and this right here, if it's an even number, so 2, 4, 6, 8, 10, 12, so on and so forth, if that is an even number, then you can't do it for right now. Right, because if you think about it, if I broke this up, okay, I would have 5 and 5, but if they're both positive, it goes to positive 25. If they're both negative, that goes to positive 25. Right? So the only way it would be is to do a positive and a negative, but the thing says that you have to have a number multiplied by itself. 5 times negative 5 is not multiplying a number by itself, it's multiplying a number by its opposite. Okay, so there's no way to multiply two of the exact same numbers and get a negative number if it's an even number, if it's an even root, right? If I do it 3 times, though, I can go back to a negative. So it only works under an even root. Oh, I didn't write the last part. Under an even root. Okay, so for those, we're just going to write the no solution, which really means not a real solution. Right? When we introduced this, we actually said that that thing means not a real solution, not necessarily no solution. But, okay, that's basically what we're looking at. There's not going to be a real solution here. Okay, so that on your own, square root of 64, if you need to, you break it down, right? 8 and 8, you get one group of 2 8s. Square root of 64 is just 8. So if you have a fraction in there, same sort of thing. What fraction would multiply to 25 ninths? Well, the square root of 25 is 5, and the square root of 9 is just 3. Alright, so you just kind of work the top and bottom separately. Okay, square root of x squared. So the variables work the same way, right? X squared means square root of x times x. I'm still looking for groups of 2. Right, so x times x. So x would be the number that multiplied, or the variable that multiplied by itself gets me to x squared. Okay, and another way to think about it is that if the root and the exponent match like that, they kind of just cancel each other out because those are opposite operations. Right, the opposite of squaring is square rooting. The opposite of square rooting is squaring. All right, so they, not, I don't want to say cancel, but they are opposite, so they kind of just counteract each other. It's kind of like adding 2 and subtracting 2. Okay, it really does nothing, right? So then, same thing for each one. So if I've got a variable and a number, you break them apart. All right, square root of 9 is 3. Okay, for the x to the 4th, you can either write out 4 x's and circle up your group. So now if there's more than one group, each one comes out and multiplies together. So x times x, because that would give me 1x out of the root. This would give me 1x out of root. X times x makes x squared. All right, and if you think about x squared times x squared would get me x to the 4th. So x squared times itself gets me to x to the 4th. Okay, so that's what you're looking for there. Another way to do that is, and you'll see it, that it helps out as we go along, right? How many groups of 2 can I get out of 4? Because that's basically what we're doing, is grouping them, right, which is division. So how many groups of 2 can I get out of 4? I can get 2. Okay, so try that on your own, and then hit pause if you need to. Right, so then the square root of 4 is 2, and then 2 goes into 6 3 times, so we get x to the 3rd. Again, if you need to, you can write out 6 x's. 1, 2, 3, 4, 5, 6. Circle up your groups of 2. Right, that would give me 3 groups of 2 there, so I get x to the 3rd power. Okay, so same thing on this, only now since this right here is a root 3, this is a cubed root is how you say that. Right, so a cubed root. Okay, so now we need 3 to get out. Right? So in order to get out of the root on a square root, right, we needed a group of 2. What number multiplied by itself twice? Right, so now I'm looking for what number multiplied 3 times would get me to 125. Well, let's break this down. All right, 5 times 25, which gives me 5 and 5. Right, so 5 times 5 times 5 would equal 125. So the cubed root of 125 is just 5. Right, so I got one group of 3 5s, the 5 comes out. Okay, 5 times 5 times 5 is 125. All right, so you do the same sort of thing. Now, here's that negative under an odd root. So here it's okay, right, because if I break 27 down, just kind of ignore the negative for just a second, right? So then when I get to this point, negative 3 times negative 3 times negative 3, well, since they're all negatives, right, negative times negative is positive 9 times a negative would be negative 27. So negative 3 multiplies out 3 times to give me negative 27. So negative 3 on the outside. All right, and then 3 into 9, I can get 3 groups of 3. Again, if you need to, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you circle your groups of 3. There's 1, there's 2, there's 3. There's 3 groups of 3 x cubes. Okay, so you just work your way along, look at the root that tells you how many you need, right? So now we need 4 to get out, because it's a root 4, and you just keep working your way down. Break them down. 9 and 9, 3 and 3, 3 and 3, one group of 4. So I take the 3 out, right? And I can take one group of, sorry, I don't know why I wrote that. All right, I can take 1, 3 out, and then 4 goes into 4 once, so I can take an x to the 1st power out. If I wrote it out, 1, 2, 3, 4, that makes one group of 4 x's. So I get 3x as my answer. Okay, same thing here, only this is a negative under an even root, so that's an automatic no solution. I would make yourself a note, negative under even root. Right, so negative under an even root there, so you can't do it, just no solution. Okay, there's 2 on your own, so I'd hit the pause button and try those, and then come back and see if you get the correct answer. All right, here we go. All right, we kind of already did this one, so you really don't have to break it down again, right? The cubed root of 125 is just 5, and then 3 goes into 6 twice, so you get x to the 2nd power. Okay, here, 243, remember that if you're not real sure when you have bigger numbers like this and you're not sure what it goes into, try your smallest prime numbers first, right? Would 2 go into it? No, because it's odd. Would 3 go into it? Yes, because 3 goes into 24 8 times and into 3 once. Right, again, don't worry about the negative till you get to the end. Since it's an odd root, it's okay. So you just break this thing down, 9, 3, 3, 3, and 3. Right, and that would just make those all negative. Right, so those would all just be negative. So negative 3 multiplied 5 times would give me negative negative 243, so negative 3. And then 5 goes into 5 once, so I get x to the first power outside. Okay, now those last two, I kind of talked about it up there with the square root of x squared, right? When the root and the exponent match, right, they kind of just cancel each other out, right? You're kind of undoing what you've done, because if I do the fourth root of this, because this is asking me what multiplied 4 times gives me this, and this is saying this multiplied by 4 times. So really those things kind of counteract each other, and you just get what's left inside. That only works because there's parentheses in there, right? Fourth root of 2x minus 7 to the fourth power. If there were not parentheses, that would not be the same thing. Okay, so keep that in mind. So same thing on that last one, fifth root of x plus 2 to the fifth is just x plus 2. Okay, so that's the end of 2.1. That's the basics on breaking them down. Okay, all of those, of course, are perfect, and the next part we'll look at some that are not so perfect.